Yo, what's up guys? And right here I have a fully working character display. So over here these are the controls. I can give it a position on the screen. So maybe I want to give it second row and two over, so third spot. So after we've selected our position, we can then select our characters. This is in the ASCII code. So I can give it maybe a capital A, and then I can load it to the screen. And if we just give it a second, it loads the A to the screen. But you guys may be wondering, okay, well, how does this work? Well, let me show you. It all started when I was reading a book called How Do It Know by J. Clark Scott. And one of the sections was discussing how screens work, how computer screens work. And so that made me think, okay, well, can I make this in Minecraft? How he explained it was that there was a RAM module attached to the screen. Each byte of the RAM module contained a segment of the screen. So the very first byte of the RAM contained the first 8 pixels of the screen. Of course, that's if you're just doing a on and off, so each pixel is a bit. But as you get more complicated, like maybe gray, like black and white, then you have a byte per pixel. Or if you're like a RGB pixel, that's 3 bytes. But right now I'm just working with a bit per pixel. And so the first byte of the RAM would be the first 8 pixels of the screen. And so I tried to figure out how to make this in Minecraft. So this was my very first attempt, which was not working. So I moved on to this one, which I was successfully able to create. Now the issue with this screen is it worked like a normal computer screen. And one of the major downsides of using Minecraft Redstone is that it's very, very slow. Major components like repeaters or comparators require a 1 tick delay, and at the minimum, with repeaters you increase that delay, but they have a slight delay, and so when you have hundreds of these in your builds, they really stack up. So then this makes these screens very, very slow. So how this screen worked is it had the screen in RAM, and it would constantly be refreshing. It would constantly be displaying the first memory cell, loading on the screen, then the second memory cell, and then loading on the screen, then the third, and then the fourth, and the fifth. Whenever I wanted to add a character, I would pause the cycle, and then I would load a character from this large ROM module, and it would be broken up into 4 segments of 4, and it would slowly be loaded into the memory. The issue with this is that it had to load every single byte, or in this case I was just using groups of 4 bits. It would have to load every single cell from the RAM onto the screen, and then it would immediately refresh. And so this took a very, very long time to load to the screen, and it was also there for a split second, because as soon as it finished loading, it would delete the whole screen, refresh, like in normal computers, where they load to the screen really quickly and they refresh. And this is called a frame. And so computers can do this dozens, sometimes even hundreds of times per second, while this took many minutes to fully load, so I had to crank up the tick speed for this. So I realized that this was not a very good method. So I had to figure out a better way to create a screen. And so that brought me to this design. And so this screen is very different than my other ones I was using over there. It has the same pixel layout, so it creates a 4x4 or 2x2 pixel with this, with just one signal. And then it's connected up to 16 4x4 pixel segments. And these segments store a single character. Now, these segments can be cleared independently. So there is this decoder which is directly connected up to my position. So it can select the Y value, and then it goes down there and selects the X value. And so then this way I can clear a specific character. And so it clears every time I write to a specific spot, and so this way I can write over a character that was stored there previously. You guys know that I can clear a character, but how do I actually load a character? So you should note that the screen is broken up into 64 segments of 4 pixels, which you multiply that out, that's 256 pixels, which is 16 times 16. And so how this is broken up is that each segment is 4 horizontal pixels. And so there's 4 columns for these horizontal pixels because it's 16 wide, and then there's 16 y values. There's 16 levels for these segments, these 4 horizontal pixels to go in because it's 16 tall. Now I can use a combination of these, to load 4x4 characters. And it's just a really simple algorithm, I guess. By you load the top segment, then you add 1, then load the next segment, and then add 1, then load the next segment, then add 1, and load the next segment. And that way you can get a 4x4 pixel loaded. Now, where do I get these combinations from? Well, it comes from all the way over here in this ROM module, which is the exact one I showed you earlier. So this ROM contains normal numbers, 0 through 9, and capital letters. I can always add more. But this ROM stores 16 bits. And so these 16 bits are brought down, kind of broken up into 4 sections of 4 bits, and they're held onto. Now there's this shift register under them, which I send a pulse to. It unlocks these repeaters briefly and just moves the signal. And this way I can kind of move, I can unlock this one, I can unlock this one, I can unlock this one, then unlock this one, and then move it around to a temporary holding spot. And so this way I can sequentially load the whole character. Now, how do I choose what segment to load to? So now what I can do is, by sending signals to that shift register, I can get the top 4 bits, then the next 4 bits, and the next 4 bits, and the next 4 bits. But how do I actually load them on the screen? How do I select the Y value? Well, that is thanks to this really simple adder over here, which actually takes the 4 position bits over here and kind of breaks them up. So the bottom 2 bits go to a decoder at the bottom here, which that selects which column you're in. Then the top 2 bits go to the top 2 bits of this 4-bit adder. And so then what this will do is it will start off with whatever the top 2 bits are, and then 0, 0. And so that selects a multiple of 4, and then that opens up our first Y value, and then it adds 1, which then goes down 1, and then adds another 1, which then goes down 1, and then adds 1, which goes down to the very bottom part. And so this way it will cover 4 different Y values. And so at the same time these signals are being sent, they're being sent into the shift register. So the adder and the shift register are connected. So in this way I can shift down and then load a number, then shift down, then load a number, and shift down, then load a number. And so in this way, using a combination of all those signals, I can load a character on the screen. So if we write a C over, it's first going to delete everything because it decodes that, turns it into a specific character to delete, and then is slowly loading the C. So like you saw, it loads the top 4, then the next 4, then the next 4, and then the next 4. And so this way I can create characters being loaded on a screen. So we have our C there. Maybe I want to write another character. So maybe I want to go to the first spot of the second line, and I can write in a, and then let me press the button, and so then it clears it, and then it starts loading in the A. And you guys can now see that it loads, like I said before, the C, the top 4, then the next 4, then the next 4, and the next 4. So you guys can kind of see, you kind of understand now why it loads like that. And then maybe I can go to the next spot over and put in a B. Now, one issue with this screen is that the pixels are all right next to each other. There's no gaps in between the A and B or the B and C. And same thing with there's no vertical gaps between the one above it and the one below it. So I might need to fix that in the future, but it's fine for now. So that was my screen. I kind of showed you guys how I made it, what it does, how it works, what it can do. And so I will probably be using this in the future with my CPU to make some more complicated designs or programs. But that's about it. Peace.